Okay, this is section 1.4, solving absolute value equations, and we're going to look at two different methods. First of all, to give you a background, we're going to use geometric definitions of absolute value to talk about what absolute value means geometrically with a number line, and then use that definition to help us build and then solve using algebraic methods. So first of all, solving absolute value equations using a number line. The definition of absolute value as a geometric definition is the absolute value of an integer is the distance between the number and 0 on a number line. And the absolute value of a number a would be written with the absolute value bars around the a. When we consider the graph as a geometric definition, we want to consider the numbers on a number line that are 4 units from 0 in either direction as an example. So looking at this number line, 0, and we'll be calling this our center point. So we want to know what numbers are 4 units away from 0 in either direction. So if we go 4 units to the left, that's -4, and 4 units to the right, that's +4. So the distance between -4 and 0 is 4. The distance between 4 and 0 is 4. So numerically, we would say that the absolute value of -4 is 4. It's also true that the absolute value of +4 is 4, because 4 is 4 units away from 0, and -4 is 4 units away from 0. Symbolically, we can say that the absolute value of -4, we look at the difference between -4 and 0. So absolute value means the distance between them. So in between the bars, we're saying what's the distance between -4 and 0, and that's 4. And then for +4, the distance between +4 and 0 is equal to 4. So the graph showing our 0 as the center point, and then looking at 4 units away from 0 in either direction, and describing it in words, the distance between -4 and 0 is 4. The distance between 4 and 0 is 4. And then using our absolute value bars to represent finding the absolute value as absolute value -4, which means the distance between -4 and 0, and absolute value of +4 is the distance between +4 and 0. So again, the distance between -4 and 0 is 4, and the distance between 4 and 0 is 4. So algebraically, if we have some number x, the absolute value of x would be the distance that x is, some number is away from 0. And so then we have an algebra equation to solve. So this expression represents what number is a distance that, let me repeat that, the distance from some number and x is 0. Okay, so as an example, let's use a number line to graph the solution for each absolute value equation below. Okay, so we have absolute value of x equals 5, and that means the absolute value of x minus 0, which is what is the distance between x and 0, is equal to 5. The distance from some number and x and 0 equals 5. So looking at a graph of that, 0, because it's the distance, some number x from 0, so 0 is our middle point. On the right side, the constant on the right side of this absolute value equation, this is the distance. So when we have an absolute value expression equal to a number, so over here, simply put, absolute value of x is equal to some constant. That constant is going to be the distance that we are going to move from our center point, which is 0. So 5 units to the left and 5 units to the right. So there are two solutions. X could be -5 and x could be 5, because -5 is 5 units from 0 and 5 is 5 units from 0. So now let's look at this one. It's slightly different. We have the absolute value of x minus 3 is equal to 5. So instead of absolute value of x minus 0 equals 5, we have absolute value of x minus 3 equals 5. This means the distance from some number x and 0 is equal to 5. So graphically on a number line. 3 is the middle point. It's the distance that some number is from 3. So 3 is our middle point, and then I can find the solutions by using my distance of 5 and going 5 units to the left, which takes me to -2, and 5 units to the right, which takes me to +8. So there are two solutions again, x equals -2 and x equals 8. They are both 5 units away from 3. Okay, C, the next one, we have x plus 3 equals 10. So, but as a difference between two numbers, we need to rewrite this so it is a subtraction because that's difference. So we have x minus -3 equals 10. And so the number that we're subtracting, or the difference between some number x and -3, so -3 now becomes our center point. So we use a definition of absolute value. This means the distance from some number x and -3 is equal to 10. And our graphical solution, -3 becomes the middle point, and the distance is 10. So we're going to go 10 to the left, which would give us -13, and 10 to the right, which is 7. So typically when graphing these graphs are already set up, but when you draw your number line, I always start by labeling my middle point first. Put the middle point down, and then use your distance, the value that you're going to go away, which is 10 in the part C. It was 5 in part B and 5 in part A. It's the constant on the right. And so once you have identified the middle point, then you just go that number of units away to the left and in the other direction to the right. So we also have two solutions for this one. They are x equals -13 and x equals 7. Okay, these are the practice problems on your note catcher to do. So the next part is solving absolute value equations algebraically. So again, looking at our same example, we have a number that is 4 units away from 0 to the left and to the right. So numerically, that was absolute value of -4 is equal to 4 because it's 4 units away from 0, and absolute value of 4 is equal to 4. Okay, algebraically, we said absolute value of x equals 4. And so now we can just think, well, I know that if some number x is a distance away from 4, I know that that x would just either be -4 or +4 because we can see our options above the absolute value of x equals 4. We had either -4 or we had +4 as solutions. So we can just, without graphing it, we can say, well, x would be either -4 or +4. Whatever's, we take the absolute value expression and we take out the x, and that number x could be -4, as we see up here, or x could be 4. Okay, so now we're going to look at these examples, and we always want to show the two cases to consider for the distance to the left of the center point and the distance to the right of the center point. Okay, so in this case, we're looking at we have two cases because we have a left side and we have a right side. So there's a negative side and a positive side, where the constant is rewritten with a negative, or the constant stays the same as positive. So looking at these three examples, the absolute value of x equals 5. So algebraically, without drawing the number line, we just say, well, I'm going to take out the x, and x is either equal to the opposite of this number, so x equals -5, and x is equal to +5 because we have two solutions. Part B, we take out the x, it's equal to the opposite of the number, so that's our negative side, or it's equal to 8. So x is either equal to -8 or x is equal to +8. And then part C, absolute value cannot be equal to -12 because distance, if this represents a distance, distance is never measured with negative numbers. You know, in a ruler, when you measure with the ruler, you don't have any negative numbers. So distance is accounting. We count how many units there are between. The negative here just indicates the direction away from 0, where it is on the number line. But the distance can't be negative. So part C has no solution. Okay, so let's look at this one. Absolute value of x minus 3 equals 5. Okay, so we're going to take the expression inside the absolute value bars and pull that out. And we're going to set that equal to the opposite of our constant. So we have x minus 3 equals negative 5, or we take out x minus 3, it's equal to 5. So you take the expression, the variable expression inside the absolute value bars, and you're going to write your two cases, your negative case and your positive case. The only thing that changes sign is the constant on the right. Okay, so then we're going to solve each smaller equation. So we will add 3 to both sides for the case on the left, and so you get x equals 2. And we add 3 over here, and we get x equals 8. So those are our two solutions. Okay, next example, I have absolute value of x plus 3 equals 10. The expression inside the bars is x plus 3, so I'm going to take that out and set it equal to negative 10. This is my negative case, or x plus 3 equals positive 10. That's the positive case. And then you solve each equation, and we can see that we'll need to subtract 3 from both sides on the left case and the negative case, and also on the positive case. So subtracting 3 from negative 10, we're going to get x equals negative 13. Subtracting 3 from positive 10, we get x equals 7. Okay, these are the two practice problems that are left to do. All right, so now let's look at some more examples. These are the examples actually from the textbook. So let's look at their solutions. This part A is similar to what we just looked at. And so is part B, just more steps. It's a multi-step. Okay, so we're going to write the two related linear equations for x minus 4 equals 6 and then solve. So the two related linear equations, those are the two cases, your positive case and your negative case. So we take out the expression x minus 4. Now the example in the book, they set it equal to 6, or they set it equal to negative 6. They put the positive on the left and negative on the right. It doesn't matter. I just typically put the negative on the left side, the negative case, because I think left is negative and right is positive. But the constant, you're going to have one positive and one negative when you write your two linear equations. And then we solve. We add 4 to both sides here and we get 10. Add 4 to both sides here and we're going to get negative 2. And so these are the two solutions. X equals 10 and x equals negative 2. So part B, let's look at the number line first. So just to go back and look at the number line and what it means in terms as the number line. X equals 4. So 4 is that center point. The x is, we want to know the distance that x is away from 4. 4 is a center point, not negative 4, but 4. And then if we go 6 units to the left, we get negative 2. If we go 6 units to the right, we get positive 10. Now we will look at part B. The absolute value of this expression is equal to negative 5. So again, because the constant is negative and absolute values expressions cannot be equal to a negative number, so this has no solution. Okay, our next example, this one does have multi-steps. So first of all, we need to get the absolute value expression, the bars by itself. So we have to undo and use the inverse operation and add 10 to both sides. So writing the equation, we're going to add 10. To the right side, we get positive 6. And now we have only the absolute value expression on the left. So we will now separate it into the two linear equations. So we have the expression 3x plus 9 equals positive 6, or we have the expression 3x plus 9 equals negative 6. And then you solve each of the two linear equations. We'll need to subtract 9 from both sides. So subtract 9 for the first one, we get 3x equals negative 3. And on the second one, we get 3x equals negative 15 when we subtract 9 from negative 6. Next, we're going to divide each side by 3. So dividing by 3, we get x equals negative 1. Dividing by 3 here, we get x equals negative 5. So our solutions are x equals negative 1 and x equals negative 5. So this was a multi-step equation, and I'm going to emphasize that you need to be able to isolate the absolute value expression on one side of the equation, which is why we needed to add 10 to both sides first, and that left the absolute value expression on one side. And then we continued to separate it into the two linear equations, the two cases, and then solved each one. So here are some additional examples. Absolute value of x divided by 5 equals 2. So we need to undo the division, so we're going to multiply both sides by 5 so we can isolate the absolute value expression. And now we write our two cases. X is either equal to -10 or x is equal to +10. Second example, I have -2 times the absolute value of x. We need to isolate the absolute value of x, so we need to divide both sides by -2, and we'll get the absolute value of x equals 1. And then we separate it into our two cases. So we have x equals either -1 or x equals +1. Our third example, we have the absolute value of x over 9 minus 8 equals -7. So we need to isolate the absolute value expression by adding 8 to both sides. And we get the absolute value of x over 9 is equal to 1 when we add 8 to both sides. Now we have our expression absolute value by itself. We need to separate this into two cases. So the expression comes out x over 9 equals -1 or x over 9 equals +1. Remember the right side, you have a negative and you have a positive. And then we'll solve both of these equations by multiplying by 9. And our solution would be x equals -9. 9 times -1 is -9. And the other one we multiply by 9 and we get x equals 9. Last example, we have the absolute value of x plus 10 all divided by 8 equals 5. So to isolate this absolute value expression, we need to undo the division, and we're going to multiply both sides by 8. And now we're going to separate this into two linear equations. We take our expression x plus 10 out. So we have x plus 10 equals -4, so that's our opposite, or x plus 10 equals +4. And then we'll solve each of the equations just by subtracting 10 from both sides. And we get x equals -50 or x equals 30. And so that is the end of these examples.